Hey everybody, it's Joel Irway with dailyfeexamprep.com, and today we've got a member request from Valerie. Now, Valerie asked me to help her out with some confidence intervals with regards to probability and statistics. So that's what we're going to do. So thank you, Valerie. Hopefully this helps you and everybody else who may have similar questions. So just a reminder, please, if you so choose, submit your member requests so I can record a video for you and we can share it with the community. So without further ado, let's get started. So her request for help was to learn how to solve for the confidence interval for the variance of a normal distribution. Okay, so probability and statistics can get confusing, and especially with all the terminology, they don't really define itself very well. So let's try and break this down and hopefully clear it up for you guys. So some key things to remember. The formula is located on page 40 of the NCEES Supplied Reference Handbook, version 9.2, and the x squared values are found using the critical values of x squared distribution chart on page 45. And I think this is where people get tripped up the most. If they don't know to look there, they could start plugging in values and trying to solve for this x squared value, but it's actually located for you on the critical values chart. So be sure to remember that. Now, the problem that she wanted me to help her out with was find the 90% confidence interval for the variance with the following data. N is equal to 25, X bar is equal to 104, and S is equal to 12. Now, S obviously is the sample standard deviation. So the formula and variables that we're going to be using are listed here below. Confidence intervals for the variance, sigma squared of a normal distribution is equal to, this is actually a two-part confidence, a two-sided confidence interval. So it's n minus 1 times s squared divided by this funky-looking sequence that we've got below, which is x squared times x squared of point alpha divided by 2, and n minus 1. Okay, so that's where it gets really confusing. We're going to explain it in a little bit. Okay, and then it's the exact same thing on the other side, except it's n minus 1 times s squared divided by x squared times 1 minus alpha over 2 and point n minus 1. So let's go through and kind of explain that. So obviously, sigma squared is our population variance, s squared is our sample variance, x squared is found on the distribution table on page 45, and alpha is our sampling error, which is equal to 1 minus the confidence of what we're looking for. Okay, so let's walk through the solution. So step 1, we want to find what that x squared alpha over 2 n minus 1 value is. Okay, so first let's define what our alpha value is. Now alpha is going to be 1 minus our confidence value, which I mentioned earlier, and that is 1 minus 0.9, which equals 0.1. Alpha divided by 2 is simply just 0.05. N minus 1, n is our sample size, which is 25. And 25 minus 1 is 24. And so what we do is we go over to our chart on page 45 and we find those 2 points of the values and come up with our x squared value. So our x squared of the point 0.05 and 24 degrees of freedom is going to give us 36.4151. So that is our first point. So step 2, find x squared with the point 1 minus alpha over 2 and n minus 1. Okay, so we know what our alpha over 2 value is, and just simply 1 minus that value gives us 0.95. And then n minus 1 is still going to be 24. So then we go over to our chart on page 45 again and find that that value at 0.95 and 24 is equal to 13.8484. So then when we go ahead and plug our values into the formula, it actually turns out to be a very, very simple formula. So we're plugging our values. So we've got 24 times 12 squared divided by 36.4151. That's our left side of the interval. And on the right side, it's 24 times 12 squared divided by 13.8484. And we come up with 94.9 is less than or equal to our sample or our population variance, which is less than or equal to 249.56. So that is our answer. So that's how we solve for the problem. It's actually very, very simple. But I know that bottom denominator it kind of throws people off, especially if you don't know where to look. So make sure that you know where to look on the chart. So some common mistakes to avoid: don't square the x bar value. So this is basically just going back and knowing that that x squared value is located on a chart. It's not anything that we calculate. So don't try and square the x bar value, and don't confuse variance with standard deviation. Variance is actually the standard deviation squared. Okay, so if you switch those variables around, you're obviously going to get the wrong answer. So just be wary of your definitions and make sure not to confuse that up. So yeah, that is the end of this video. So I try to keep these short. I would love to know what you think. So please comment up below the video. Let me know what you think and share it with your engineering friends. I'm trying to grow this community, and I'm trying to make this an interactive community and give you the best content possible. So I would love to hear your feedback, and I will see you in the next video. Thank you so much for watching, and stay tuned.